So we left off, and we were talking about volume equations. And most of the ones that we did last time were rotated around the x-axis or the y-axis. Okay, so we didn't have very many where we were shifted a little bit, like around x equals -2 or y equals 1 or anything like that. Okay, so let's try this one. So it says, find the volume of the solid obtained by rotating the region bounded by the line y equals x. Yeah? Okay, well, we'll do it again. It's fine. Y equals x, and the curve y equals the square root of x around the line x equals 1. Okay, so we have this area right here. Now, some people in my last class were kind of freaking out about like the sketches and like seeing the 3D shape. So we've talked about this. The 3D shape would be here, and it would have a cone cut out of the middle. So it's like a bowl. Oops, that was a bad bowl. I really messed it up. So we have like a bowl, and then we have a cone on the inside. So imagine you're in your art class sculpture, and you're making a bowl shape first, and then you're chiseling out the inside part to look like a cone. That's what we have. Do you guys visualize that? Do you see it? You do not have to visualize this. You do not have to draw this 3D thing. So you could leave your drawing like this. All we do, actually that would be if it was going around x, y equals x, right? So this time we're not going around y equals x, we're going around the, oh gosh, I am really struggling. Maybe I should start over here. This is a terrible video. So we're not going around the x-axis. Instead, we're going around the line x equals 1. So we're going here. Okay? So when we do that, it does still create that bowl with the cone. So we're getting a certain shape. So you don't have to draw the three-dimensional shape. What we're going to do instead is we're going to go to the outer radius, and we're going to go to the inner radius. So when we draw an outer radius end, we start from our axis of rotation, so the thing we're whipping around very quickly, and we go all the way to the outside of the shaded region. That is our outer radius. Our inner radius goes from our axis of rotation to the inside. So it's like that. So just like when we did area, and we talked about having an infinite number of rectangles, we would have a height like that, or we would have, you know, our rectangles. I don't know why I drew it like that. We could have our rectangles like that, and that would have a certain like height as well. It's on its side. Okay, and do you remember when I asked you, and I said if we're going from -2 to 10, what's that distance? 12. So if I'm trying to come up with this radius, this outer radius, I'm going from the right side and subtracting out the left side to get that distance, right? Just like 10 minus a -2. So what is on the right side? What's here? What line? 1, right? What is on the left side? Nope. Like the square root of x function, right? But if I'm going around a vertical axis, so I'm rotating around this vertical axis, does it look like the x-axis or the y-axis to us? It looks like the y-axis, right? And so when I go around a vertical axis, I integrate with respect to y. So I want to integrate this with respect to y. So I'm going to have everything in terms of y. So my y is going to go from 0 to 1. And my right, or my outer radius is going to be right side, which was 1, minus left side, which is what? Yep, exactly. I'm going to square both sides and get y squared equals x. So 1 minus y squared. And then that inner radius is going to be what? 1 minus y, right? That was the same as x equals y. So when we set it up, we have 1 minus y squared. Whoops, y squared squared. Y squared squared minus 1 minus y squared.
I'm so confused on where you got the y, big R, and little r.
The big R and the little r. So you always just go from your axis of rotation, and the big R is going to be to the outside of the shaded region. And then the little r is going to be from the axis of rotation to the inside of the shaded region. Yep. Mm-hmm.
Where do you determine, though, where that is on the curve?
Like how high or low you're located?
Yes.
It doesn't matter.
Okay.
It depends on where that point is. So like that's the x, the unknown, or the y in this case. So y is wherever I'm located, right? Between 0 and 1. So the biggest y could be is 1, the smallest y could be 0. Yeah, it's creating all of those like cross sections. So it's just saying we have an infinite number of these cross sections, right? Do you remember those circular cross sections, the discs? That's what we're creating.
Where'd you get like 1 minus y squared and 1 minus y?
So we did the right side, which was 1, and the left side, which was that y squared curve,
Okay.
like that. All right, so that's our setup. Don't forget your pi.
So it's kind of like those fans that you can like stack back together.
Yeah, like nesting doll type things. Yeah, there's something called the shell method, which is actually more like the nesting dolls. Mr. Bradley, he used to teach calculus way back at when. He has some wooden shapes. I'll have to bring them in so you can see them. I know I need to purchase my own wooden shapes. All right, so what did we get in the end? What was the answer? 46 over 15 pi. Yeah. All right, so let's do the next one. So this one says find the volume of the solid obtained by rotating around the y-axis. So when it says y-axis, we're integrating with respect to y, right? So we're going to set it up like that. The region in the first quadrant bounded by the cube root of x, which looks like this, and y equals x over 4, which looks like this. Now, when I see that I'm integrating with respect to the y-axis, I should rewrite these equations because I want x equals and then equations that have y's in them, right? So I want to solve this first one. So it's going to be x equals 4y, and I want to get this other one. So it's x equals what? Y cubed, right? That's what we're using as our functions. So let's look at our shaded region. So if I was finding the area would be this little piece right here. But I'm taking that region and I'm rotating it around super fast, rotating around the y-axis. Do you guys know what the shape is? Can you see it? What's the outside shape? Cone. So we have a cone. And then the inside shape is like a little curve like that. I don't know what that was called. So it's like that.
Do we need to know like if it's cone or what?
So you don't have to know how to draw that. You can visualize it if you want to. But if not, then you just go from your axis of rotation all the way to the outside edge and axis of rotation to the inside part. So we have our outer radius and our inner radius. Doesn't matter which one I put on the top or anything, like where you draw it.
Wait, and when you got the things in blue, did you just do the?
You can draw it wherever you want.
I'm saying like when you went from y equals 3.
That's our axis of rotation.
No, the numbers on the side.
Oh, yeah. I just cubed both sides to get rid of the cube root, right? Or I multiplied the 4 over.
So you're like finding x then?
Yeah, like finding a function in terms of y is what we would call that, like f of y equals x. All right, so our outer radius. We want to know the distance, how long this is. So if I'm talking about the distance for a horizontal segment, right, I do the right side minus the left side. So I'm going to say it's 4y minus 0, right, which is just 4y. And then the inner radius, it's going to be the right side minus the left side, right? And the right side was that y cubed. So the biggest thing that people will mess up on is they will forget to like get things in terms of y. So I used to do that a lot as well, so I don't judge. All right, so our volume is going to be pi outer radius squared minus inner radius squared. So remember, you could just write it like this, and then it's from 0 to something. You can write it like that if you have already defined what r and little r are. So Will, did you have a question?
Yeah. Do we have to worry about the bottom half that is also?
We do not, because we said the region in the first quadrant.
Oh,
So.
I did not read this.
But yeah, if it didn't say that, then when you rotate it around, wouldn't you just have double what we have here? Yep, exactly. All right, so what y value do we go to? So what is this point right here? So we need to find that, right, Grant?
1.
It's 1. Okay, so let's see. So if you have 4y equals y cubed, I don't know, is it 1? Yeah, so I'd have y, and then I have y squared minus 4. So I think I get 0, negative 2, and 2. So these are the y values. So my y value would be 2. Negative 2 is where it's crossing down here, and 0 is in the middle. So the y value is 2. You could find the x value. You actually don't need it. it would be 8. So we're going from 0 to 2. And that's another mistake people will make sometimes. They'll put x's there on accident too. So we have 0 to 2, and we have 4y is being squared minus y cubed is being squared. Anybody have it? Emerson, what'd you get? You're just guessing 7. I doubt it's 7 because there is a pi involved. That would be amazing if it was like 7. But we'll see. Ugh, I got a gross one. That is not what I had. Oh, did you multiply the pi in? So I have 512 over 21 pi. The lovely. So you could multiply the pi in, and it's 76.595, yeah. I usually like it in this form, though, because really, like, there's so many different forms for these. I like you guys to be consistent. It makes my life easier when I'm grading. You like me to be happy when I'm grading. All right, so it says determine the volume of the solid obtained by rotating the region bounded by y equals 2 times the square root of x minus 1 and y equals x minus 1 about the line x equals negative 1. So if we have 2 times the square root of x minus 1, I'm going to go ahead and graph this because I'm going to guess I need an intersection point anyway. So go ahead and graph it on your calculator. Okay, so it looks like it's crossing at maybe 1, 0. Let's check it. So if I plug in 1 for both of them, do you get 0? Yep. And then what's the other point? Do you guys have that? So the intersection point. 5, 4. Okay, so we're rotating around the line x equals negative 1. So x equals negative 1 is over on this side. So this time it's on the left side of our axis of rotation, which is fine. And this is why I'm teaching you to do the right minus left thing to get r. Because a lot of people have trouble with these. When it's on like the left side or the right side or above or below, they have trouble figuring out what those distances are. So let's think about it. If I have my distance from my axis of rotation, we always start there, and we're going to the outside of the region, that's my big R, what do you think it is? So what is that? X minus 1? Right, you have to solve for in terms of y, right? We need everything in terms of y. So I'm going to say y plus 1. So that was the right side, y plus 1. Minus the left side was negative 1. So that's why Ethan was saying plus 1, because do you see what's happening? It's this distance, which was the y plus 1, and it's adding this distance, which is 1. But if you're doing the right minus left thing, every single time you'll get it right. So you have y plus 2 as our outer radius. Yeah, Caroline?
Why does it have to be in terms of y?
Because it's a vertical axis. So we're going around y or x equals negative 1, which looks like the y-axis. All right, so then if I have r, little r, axis of rotation to the inner curve. So right minus left, my inner curve is, well, we got to find it. It's y over 2 equals x minus 1. So y over 2 squared plus 1, or not squared. What am I doing? Was that? Yeah, there was a square root, right? Plus 1 equals x. So I'm going to say y over 2 squared plus 1, and then minus that negative 1 that was on the left. That's coming from this line here. So it was the right side minus the left side. So that ends up being y squared over 4 plus 2. So you can do your setup with your r squared minus r squared with the pi, right? So you could say v equals, me put the pi on the outside. Pi. I go from 0 to 4 for my y values, and I could do big R squared minus little r squared dy. So I could do that, and that would be, I would get perfect points for setup there. So because I've defined what my r's are, I'm good. All right, so if I wanted to go further and do this by hand or something, you could. I wouldn't want to do it by hand. If you have your calculator, I wouldn't do it by hand, right? Because you'd have to foil it out. It'd be messy. It's probably not something that difficult. Anybody have it? Should have found these numbers before. You got what? You guys don't like to give me my fractions, do you? I got the lovely, these are all just lovely, lovely answers. 1,792 over 15 pi. There we go. Yeah, that's nice, yeah. All right, do you guys get it? You didn't get that? Did you remember your squares? Check your squares. You got it? I think I'm good. All right, we'll stop there. Let me give you your homework. Well, no, you guys already have